Well, yeah, I mean, thanks for inviting me here. Hopefully everybody's having a great event so far. And as always, great to see you.
Great to see you too. It's been, I'm sure you're like super tired of this, but it's been amazing to see what transformers have done for the world. And they're going to continue to for the world, so thank you for that. And yeah, how are you, like, yeah, maybe a question for you. How has your mind changed over the last year or two in how you think the world is going to unfold over the next 2 to 4 years? What did maybe you used to believe that you no longer believe? Or what do you think is like accelerating in terms of, yeah, like how has your world model changing? Part of why I want to ask that is I want to help, you and I spend a lot of time thinking about this sort of stuff, and whatever we can help distill out for people, the better people are going to be able to make decisions.
Yeah, I mean, I actually tweeted this because I've been thinking about AI since I was 10, after I watched like artificial intelligence movie. And for me, kind of, a lot of the things that are happening are just like, it's more like it's kind of happening too slow type thing, not just like, hey, this is, you know, new, like conceptually new things. So it's really hard to say like, hey, I changed my mind. It's more, actually what did change my mind is crypto. When, like, because I worked kind of on, you know, full time on AI effectively for 10 years before going into crypto. And effectively, my model was always, well, you know, you need to build a profitable company to effectively enact change, right? And so, like, you know, if I imagine, okay, how does this work, and how would this work, and how would this come to market, I would actually normally would think more like OpenAI, Google style. But as you know, as I was learning, and when we were working on Near AI originally in 2017. We needed to engage a lot of people around the world to kind of contribute to our work with data labeling. And we had challenge paying them. And so crypto was like, hey, you know, this is a kind of way to pay everyone globally. You know, don't need to bother about borders, don't need to bother about like specific restrictions that every country has. You know, you just pay them, and kind of they need to, I mean, they still need to figure out how to off-ramp, but at least like that's a solvable problem that people know how to do. But as kind of you go deeper down the stack, right, you realize, well, and I think, I forgot which year was that, but I remember it was in Paris during one of the ECC conferences, and you had this talk about like borrowing from the future. And so this idea that like, hey, actually the capital formation can itself be different because you are able to, instead of creating this corporation that forever needs to grow or it will die, right? You now have a different model where you have people effectively contributing capital to build something that they can use later. And it doesn't need to effectively, you know, absorb the whole planet or die. It can actually maintain some status and live as a network. And so I think like that's a conceptual change, and kind of I now pitch this back to traditional AI people because like, hey, look, what's happening right now is actually very scary. If you have, you know, handful of companies that are controlling effectively the intelligence tooling that we all going to use, and I mean, literally, we right now in, for example, Thailand, you know, you go across the border, you don't have access to OpenAI anymore, right? They can, you know, right now shut it down for everyone in this country. They can decide that, you know, it shouldn't respond with medical answers to you, or if they want to change something for whatever reason, I'm not even saying it's malicious, it's more like business reasons, right? For example, I was suggesting this idea that like, hey, you know, closed, you know, corporations will actually inject ads into the models, and then like I was suggesting as like, you know, kind of thought experiment, and then I learned somebody actually was doing that. I was like, hopefully not from my suggestion. But like in general, right, like we have no idea like how the decisions are made. And again, working at Google before, I know how I was making decisions. And I was like, well, I need to filter out Fox News because they're saying Barack Obama was born in Kenya, and it's, you know, reducing quality of my data. And so the easiest thing is just, you know, cut out all of the right-wing media. Now the model is super liberal, like not because I'm liberal, but because like this is how I cleaned my data, right?
Yeah. How do you see the importance of open source training and open source inference shifting with time, right? So a key point that you're making is you have these labs controlling the build out of the models and who gets to use them. The OpenAI example can today be averted thanks to Llama, so people can download Llama and then use it, and maybe you get an OpenAI equivalent. But it also depends on Facebook's extended generosity in continuing to train cutting-edge models. Yeah, how do you think about that?
Yeah, so we're announcing something tomorrow.
The alpha.
Yeah, this is not live streamed, right?
Yeah.
Yes?
It is live streamed.
All right, well, watch tomorrow the redacted talk. But I would say kind of high level.
The prediction markets are going crazy right now.
High level, this is a big problem. And the problem is it's also nobody actually knows what Facebook trained it on. It's also GPT-4 is actually a smaller model than the Llama 400B, and Llama 400B is way worse. It's barely better than 70B and worse than another 70B models now. So the reality is, we don't know, we can't improve on it effectively because we don't actually know what it was trained on, where the issues are, etc. So it's not really open source. It's open weights.
Yep.
Now, if you step back, why we want open source? We want open source because we want the guarantees that it does what it does. This is kind of the bias in the data that went in, and so we know how it works. We want to be able to permissionlessly access it, and we want to have a way to build on top of it and fine-tune it and do all those things. Now, the challenge with open source, and this is global challenge with all open source, is that it's not monetizable, right? You build something, any corporation can grab it and use it, and there's no attribution kind of back to this. Now, there is a somewhat new kind of way of doing things, which is called trusted execution environments. And specifically this year, kind of new Intel chips have new kind of model of this, as well as the H100s and GPUs working together. You can create an environment where you can actually execute code that the host machine that runs this code doesn't know what it runs, it doesn't know what data it runs on, and you as external party can have guarantees that this code was executed. So traditionally, this was either impossible or was very complicated. The previous generation of TEs were completely unusable. So this is a fundamental change that happened within previous 6-8 months. What this enables is actually we can train a model inside a TE, right? Where you know what code it runs, you know what data it runs, but the model parameters are not open. They're encrypted, and they're only available inside TEs. Now, if you have your own TE, you can download it there and run it. So you have permissionlessness. If you have, and you can get it from anyone else who has the same TE, or bring it on a flash drive encrypted. If you have, you can fine-tune it inside TE as well, so you can build on top of it. You know what data went in, you know what code went in, so all of the properties we wanted are there. And the one extra thing now you can do is you actually can monetize it. You can actually charge with a payment channel for every inference, for every token, effectively creating a business model that actually creates revenue stream back to fund the research and fund the training new model. And so now you can pool capital, right? Going back to what you were just saying, pool capital to train the bigger and bigger models with a business model that it actually will return. So that is fundamentally what's needed, and this is what blockchain actually uniquely enables, right? I mean, this combination with this hardware to actually create business model and pool resources, borrow from the future revenue stream to actually have truly open source approach.
That's pretty awesome. So if we, unclear what's going to get announced tomorrow, but if we can ship a cutting edge model trained in this kind of verifiable computing style and making that a networked-owned resource, that could be transformative for the landscape today. So I think that would be super valuable. How do you think about both deciding what goes into the training set? I mean, certainly you can train many models over time. As things get cheaper, you can train many of them. And maybe how do you decide the inference part of the equation, where there are some concrete, there are certainly some regulations in specific locations that maybe are warranted and maybe shouldn't be warranted, right? Like preventing access to medical information in LLM is a deeply fraught ethical quandary, right? If you do it and there's a mistake in the LLM, you could cause a lot of harm. If you don't do it, then you're also causing harms of omission massively.
Well, yeah, especially where people don't have access to doctors. Like there's
Massively.
I was talking with someone who runs AI Assistant, and their African user base massively uses as just a doctor.
Yeah.
Because they don't have access to any
100%.
qualified doctors.
And that probably, has anyone done a graph on like how that is improving? What impact that is having on the actual health?
I mean, I don't know if there's like way to track that down to like local data on hospital visits and stuff, but
Deepen for human
hospitals?
metrics, right? Like deepen for like World Bank data. Why not?
let's do it. Chip to everyone, right? Oh, sorry, that's from a different story. Different story. It's deep in. It's fine. Peer to peer. No, but so two questions, right? So one actually is interesting because the T's also enforce privacy. Because now instead of you sending all the data to, again, one of these companies, it actually goes to their databases, right? This actually goes now into TE. It's encrypted end to end. And so you can always keep your data, but there's no other third party that ever sees this data. And there's no kind of additional enforcement that can be done on that. And now you go back to like what models should be available through this path. And there is a question of like kind of safety and ethics that is there and that is important. Sadly, a more important problem right now for this is how to get a good model. Again, right now, open source models are way less effective than closed source model. Even trained by large centralized lab, right, spending whatever, hundreds of millions of dollars. So and this goes back again to approach, like building another centralized lab will not work, right? I mean, you're not different than from so how do we use?
There's only so many large tech companies that are going to bankroll you.
Yeah, I mean, you're going to be pretty much competing for the same talent in the same way, like just throwing millions of dollars.
The same 4 offices to go pitch them for money. Like,
yeah. And so how do we actually use the same approach, right? This, kind of we've been using in blockchain in such a way where we can incentivize people to come up with new ideas, come up with new methods, come up with new data cleaning procedures, with new crowdsourcing procedures, and effectively, at the same time, collaborate and compete, right? This is what kind of blockchain is, like this cooperative competition that we create, like for block production, for everything we do. And so, again, the thing we're going to be launching is competition related. It creates kind of effective, like a model, and we're going to be iterating on how it works to pull talent from anywhere it can, give them resources to be able to train these models, to be able to iterate. You can then, again, see the results. You can apply whatever the set of requirements that, the community thinks, like, again, somebody is funding this model. So, for example, if government of some country says, like, hey, we want to fund, for example, a model that speaks Thai really well, they can also enforce, like, and we wanted to not do this and do this. Yeah. Cool. That's, they can see all of these restrictions, and then it's
so you break down the problem of the ethics and safety policy space into local jurisdictions deciding.
Or communities, again, like a crypto community can say, like, hey, we're going to fund like the most crypto-anarchic model.
Yeah. Well, how do you solve the Earth level question of like, it'd be great if these things don't kill us?
So I think actually that don't kill us is a different question, right? So there's like few levels of safety to think through. One is, first of all, I actually fundamentally disagree with like AI will go and think of killing us, because this is the most like, it's a lot of energy extended and there's no return on this. So like from effective AI decision making, there's no like, economical reason to do that.
Yeah. We could dive deep into that, but it could we should make a bet sometime. This is a great bet type question. Not in this, to put you on the spot, but at some point we should have like a good fireside diving deep into this.
Okay.
With a bet.
But so there's like few different levels of kind of the safety and security system. But the interesting part is this is something that like I know people from OpenAI, their position is, hey, we don't want to open source. Like they're trying to convince themselves this is not for business reasons. So they say, hey, we don't want to open source because people can use this to now break code and do some other malicious things. And so the reality is actually, yes, this models
but
are
that is
getting...
also true. Yes, I understand the business model.
So let me get there. Yes, so these models are getting better and better at actually breaking code. Like I actually tested this and like it actually finds existing vulnerabilities pretty, like that, it didn't see in training data. So that's a startup on itself. And the question is like, okay, what do we do with that? Like, how do we actually, from base principles, solve this problem? And this relates to kind of AI safety in general. And the answer is math. There's one thing you cannot break, which is math. Everything else, code is breakable, everything else is breakable, math is not. And so what we need is we need to actually have a formal proofs for every single line of code, for every single program, and for every single interaction that any agent, be that human agent or AI agent, can take. Now, how does this work? Well, we as humans are pretty bad at formal proving, so we actually need AI to help us. So that's a separate, and we'll talk about that in coming weeks, on how to do AI, kind of use AI for formal proving and how.
I think it's a great direction.
Yeah, great direction, a lot. But the interesting thing is how do you apply it back to everything we do? Yep. And the interesting thing is right now on the blockchain, when you're sending transaction, you actually don't have any guarantees. Like, yes, it will execute the smart contract, and the smart contract can do it. Like, there's a code there that may have a bug and can do whatever.
Yeah, that's very useful.
And so what you can do now, you can actually have the guarantees on a transaction where you say, hey, I require that everything I interact with from here on out satisfies this set of principles. And so smart contract needs to have a proof that it will not lose your money, right? And if it doesn't, your transaction will literally not compute.
Oh, that's really neat.
Blockchain will reject.
Formal verification at runtime, that's a great idea.
At runtime. But now let's extend it. Go off-chain. When you're interacting with other AI agents, they need to also compute and provide you a proof that they're not going to do X, Y, Z.
Ooh, that's harder.
It's harder, but it's still possible, right? And again, this is like we're using AI to do formal verification. But again, like they're still doing a state transition one way or another. And this state transition may involve dispute resolution. It may involve kind of, and so effectively you're making this intents, which are having set of restrictions and have a set of conditions, and they're matching with whatever agents, solvers, services, whoever is executing, executing them, and then you have settlement process that verifies that it's correct. So there's a whole framework that we need to build kind of from the ground up to kind of have a way to specify set of mathematical kind of requirements, which may be loose in some places where you want them to be loose, and very concrete where you need them to be concrete, to actually ensure. And then, if people say like, hey, this is our definition of safety, like it should not do this and this, cool. Write it in math, deploy it on all the TEs, and now the model will, be actually restricted from doing that.
Yep.
So that's kind of how I see this. Is like we'll progressively mathematically define what we actually mean by all these things, and then we can ensure that the machinery we're using, the code we're using, is actually satisfying it.
Two questions building on this, and that makes a ton of sense, and I think it's going to be a really useful direction. One question is around economics, and I'll kind of paint the direction and then describe the other one. And we can go down each path in whatever order you think is best. One path is how do we orient the economic value of these models and the inference that they're going to make? How do we orient that to align with humans broadly defined, both in the short term with groups of builders that are building commons, or societies at large, cities, states, and whatnot, countries, and then second, there's about to be a large proliferation of many different fairly intelligent agents with their own access to capital and resources, and that could that also has a question of. From one perspective, who are we to tell a new species to not have rights? That always isn't a good idea. And then separately, how do we orient and align the broad ethical and economic interests of the community of millions of agents that are going to be appearing over the next 2 to 6 years? So I don't know which one you want to dive into first. What's harder? What's easier? Aligning humans or aligning AIs and humans? I mean,
there's this. The joke I use is. Blockchain is ultimate meritocracy, because it doesn't matter who's on the other side. It can be human, it can be a cat, it can be AI. It doesn't matter, right? If you have made commitments, if you made transaction, you're executing it, you have an address on chain. That's kind of all you need to know to actually transact. Now, obviously, it's a little bit simplifying things, but broadly speaking, what we see now, right, these AI agents will be indistinguishable from humans on the other side. And, yes, there's like, we need to apply all these restrictions and proving, et cetera, to like make it more robust. And so the question here is, how do we formulate effectively a value function, right? A goal that is both makes individuals successful, people and AI agents, and is kind of globally not trying to destroy the world, right? And so I think that is a really interesting research problem. I don't like have an immediate answer,
Yep.
but at least like kind of the way I'm looking into this is to start by inversing the current system, which is like corporate focused, right? You kind of
and single country focused, right? I mean, there's a deep geopolitical inequity there that it all works out well. The borders are free and the commerce is free, but the moment you get shut off from the AI pipe, like that sucks for you as a nation state.
Well, yeah, or internet, or everything. Yeah. So, or money for that matter. And so the question is, like how do we make it individually focused? How do we make models and kind of agents and systems that are focused on how do we make individual more successful, more monetary successful, as well as like general well-being as well, be that health or be that mental health, et cetera, right? And so that's kind of, that's why I like call it user-owned AI. Like to me, that's kind of the first focus, and then we do need to define kind of a global function as well that kind of maybe puts constraints on the overall system. Again, I'm probably not the one to do that, but it is something interesting to figure out. Kind of how do we balance this like individual community level with kind of global, we are in one constrained system, and so we need to like at the same time satisfy set of requirements there.
And for how do you see this evolving over time with agents emerging? Like, do you buy the notion that there will be a ton of these little agents, or do you think it's going to be more, glummed up into larger singletons?
No, I think so. The way I describe it, because like agent is such a like wide term, and it like covers a lot of things. Yeah. There is effectively like agent services, right? So this can be like effectively any store, any even individual can become an agent service. An agent service is like providing something to everybody else in some specific way, and it has a natural language interface, but you can pay for it. You can it requires a set of requirements. For example, I only work with KYC people or whatever, right? Like there's kind of that framework. That's something we're working on. There's agents that are effectively just tools for yourself, right? So this is less of. And then there's autonomous agents, which are effectively like nonprofits that can be generating their own profit and reinvesting it into something, right? And so those are completely different, and kind of the way that they work. They can raise their own money by issuing a token. They can use this money to like invest and do things. They can capture this profit and reinvest it, et cetera. Yep. And so I think it's like really important to distinguish these different types.
I mean more like the latter case where you have AI-powered entities that are going to start being economically relevant on their own right, and they have their own entity-ness.
Yeah. So those are really interesting, and I think there's like a set of use cases where this is extremely valuable and important, right? Any kind of support, any kind of distribution of like when there's a catastrophic event, the war breaks out, those kind of things are really interesting as a model where like this AI agent can coordinate relief and even some people on the ground to do things. And again, this is because like it kind of fits this nonprofit structure really well.
That's interesting. That use case is actually very interesting for the community here. So you and I are both very keenly aware of how coordination super breaks down in any kind of high conflict scenario, any kind of war. And while maybe the core of the conflict gets attention, all kinds of other things start falling apart. And we now have the internet connectivity globally, and we have good ways of getting information around, but we lack good coordination tools to actually get people to operate well. How do you think like these tools can help the people here build these kinds of better coordination systems and frameworks for either jumping in on like an emergency scenario or just better governing and growing in commons in general?
Yeah. Again, there's a lot of work to be done, but effectively the part that's interesting is what usually breaks down is when you need to coordinate a lot of people is that one individual can only talk to that many people. Yep. It also, like, as running organizations, we know when you do town hall types meetings, most people don't listen. So you need to repeat like 7 times. But the interesting thing was effectively, even now, with an AI model and like a little bit of configuration to make it agentic and have some memory and have some kind of tools, is that it can effectively manage any number of people, right? It can know exactly what any individual is tasked to do, and it can, check up on them. And it also can do that across, 10,000 people, 100,000 people without any hierarchy, right? You don't have any broken telephone anymore kind of through the hierarchical structure of organizations. And so now the question is, like, how does it make decisions? Is it making decisions effectively? Those are like research problems on making these models more higher quality. But from perspective of, like, you have an individual, like an app that actually, like, hey, I'm your whatever, helping people assistant, and here's a task for you today, and there's $5 for you if you do it, and there's another person who gets the same to like validate that you did the task, for example, or whatever, and they get paid 50 cents for that. And so, like, you can actually coordinate like a pretty big crowd of people who each one, they may still even have a context of what they're doing. They can ask, like, oh, why am I doing this? And they're like, well, you're doing this because 50 people will come and do this 5 different things, and together this will achieve this, right? So, like,
that's super cool.
That's as a part of which is right now people like don't fully understand why they're doing some stuff, and it's like because they're missing context, they're missing maybe motivation.
I think this is buildable now. Like, you could probably build this.
You can build this now. Yes,
that's awesome.
Yeah. So if somebody wants to build it, let me know.
You could solve so many large-scale coordination problems in these kinds of ways.
Yeah, and so I call this AI CEO.
Yeah.
And so, like, I'm also interested because if you think of if you think of a blockchain cannot have a human to be in charge of it.
Yeah.
But it can have an AI in charge of it.
Yeah.
That is fully verifiable. You know what come in. You have token holders effectively being able to vote on.
I would call that like a digital corporation, like a digital AI powered corporation.
Yeah. And so
the DAX are finally coming. It's been like 10 years.
and so and like whoever, somebody sets it up, either another AI corporation or a person, and they define set of mission and goal and how to evaluate its success. Yeah, and then you just unleash it.
It's really cool that these models, you can get a very strong sense of like impartiality and effectiveness and so on, especially if you combine the verifiability properties. Like, that's amazing. That could like rewrite how we do all human organization today. It would be super, super cool. So, I was going to ask, are you open to audience questions?
Yeah. Just maybe to mention, so one thing that kind of within this, like even before AI coordination, one thing we've been kind of in the ecosystem testing is this idea of small tasks. Because we're going back to where we started, we were doing crowdsourcing, data labeling, and a lot of it is just a small task that person does. And the problem is, like, people lazy, they don't want to do stuff, they like skip, they want to make more money. And so for about 3 years, this project called NearCrowd been testing effectively how to build a game theory of people doing work and then other people validating it, and this system not collapsing. Because people come up with all kind of creative ways to collapse the system. There's honeypots, there's effectively like game theories, there's something at stake, etc. But this kind of framework itself can serve now for AIs to give tasks, because people then go do them, and then somebody verifies. There's again some money involved for paying, etc. So like a lot of these pieces are coming together and kind of creating this effectively more distributed framework of doing work.
Yeah, it's really exciting. All right, let's take some audience questions. I think back there. Can we get a mic running around other than R2? Here, take this one, and I'll get out the other one. Thanks.
Thank you. So a few questions. So one is with the advent of we have these like new neural architecture network architectures like liquid neural networks and some of the Mamba or Cans or whatever. Where do you see those going in comparison? Because you brought up like Llama 405B, super expensive to train, etc. So do you see like new neural architecture network, new architectures kind of supplanting the old ones and then potentially reducing the risk of the necessity of centralized training? And then second question is, how do we deal with this kind of like the problem of like the really like rogue malicious actor who, in the same way that people can create viruses on their own if they have enough resources, and that's a massive threat. Like a rogue individual actor with enough resources to create AIs that can like really do a huge amount of damage. And how do we mitigate that, or can we do anything about that?
Yeah, so good questions. I mean, answering the second one first, our world in general already has some mechanisms around that, right? And I think my point is actually the more every individual is equipped with AI tools and the more we figure out how to make those two tools to coordinate, the easier it will be to find if somebody rogue is trying to do something, right? It's like the same, if, like, because majority of people are not trying to do, like, to destroy the world, right? So if your majority of people have, like, more computational resources to actually, understand and optimize for individual and overall success, right? They can identify when somebody is trying to, like, zero out the value function. So, I mean, there's few things around, like I really don't believe in, like, restricting compute and doing all this. This just, like, doesn't work, and there's always kind of, but I think, like, there's some combination of, like, how normal, police and investigation work if they're equipped with AI, if they can, detect when somebody's moving in that direction. And at the same time, kind of enforce some of the, again, more like what is a formal set of rules, right, that we actually want to enforce on the whole world, but it's actually expressed in math, and like we all kind of need to agree and commit to it. Versus right now, it's like natural language, interpretations, court, all kinds of stuff, right? So, so I think that is a direction kind of I believe in and kind of I'm working on. And the first question was
different architectures.
Oh yeah. So I mean, from my perspective, like I worked on architectures, and there are new architectures coming out every like year. So the fact that like we kind of actually stayed on transformers, and that is like kind of a selling point, was actually more surprising that like there should be more stuff coming out. I think for specifically,
I guess attention was all you needed.
I mean, it seems like, yeah. I mean, the reality is, and this is like kind of more fundamentally when you go to like trillions of parameters, right, or hundreds of billions of parameters, you can express anything in that model, right? Like the amount of bits of information you can store in that is insane. And so the question was more like how to train that model. We didn't have effective ways to train it, and transformers is just like a very effective architecture for training. Now, to your point, is like are there architectures better suited for distributed training? The answer is probably yes. Maybe it's some modification transformer, maybe it's something new. But this is why we need like open up the research and actually like allow people to iterate and try new things versus like close it up, what's happening right now, and everybody just kind of zeroing in on one thing and just like churning on it.
So famously, okay, can you hear me?
Yeah.
Famously, it's very expensive to train these models. And then like TE, it seems, would probably add overhead. How much overhead does TE add to the training costs and to the inference costs, and maybe also latency?
Yeah, so right now TE with GPU is like 7-10% for inference, and we haven't fully like done a training run to measure that, but it's probably actually less because the overhead with TEs come from the encrypting, decrypting data. The GPU itself is like effectively the PCI bus is blocked only to access through the TDX, and so nobody else can just access it. And so there's no overhead on GPU itself. It's all overhead in like data marshalling and encryption, decryption. And so with B100, so new generation, the networking itself, like interconnect within cluster of the GPUs, will also be kind of encrypt, like support that where like you cannot tap it into it and see it. And so you have kind of pretty good guarantees that if you have a cluster, let's say like 4,000 machines, you can spin it up, you load all the data once, and then you you train for a while, and it doesn't incur additional overhead.
So you can amortize one encryption across all of the.
Well, you still need you need to do it in parallel on all the machines to like load different batches because you do data parallel. But kind of beyond that, like it's whatever effectively you need to marshal training data in and kind of to encrypt it into TDX, right? And then so that's why inference cost is actually more, because like you need to marshal millions of tokens back and forth.
Yeah. And then for the formal verification stuff.
So I want to give other people a chance.
Fair.
We can find one last question, and I think we're out of time.
Do you know of any feasible attempts of some work groups of how to collect trillions of dollars for public good AGI development?
I don't know of anyone who's doing trillions of dollars, but we're gonna start doing
get
this
there in like 10, 15 years.
Yeah, I think so. Right now, just to give you some numbers, right? GPT-4 is roughly like, if you assume some things, is roughly like $80 million for training, if you know what you're doing. The problem is obviously you need to do research and figure out what you're doing, but and also like obviously GPT-5 is probably like $200 million. But the point is, you don't need yet, you need hundreds of millions of dollars, which is, in crypto we actually very effectively know how to collect and contribute, and you have a repayment cycle of 6 months probably at good utilization, and so that mass is working right now, and as this thing's kind of becoming bigger, we the GPUs themselves are getting cheaper as well.
Fee structures on top of whatever applications emerge, right? It's super easy to add good fee structures on top of useful products. In the way that currently, when you build on top of a normal OpenAI style LLM, it's difficult to connect the flows of the value creation.
I mean, the thing here, you can literally tap into the already payment channel and just say you're going to pay a little bit to GPU, a little bit to model creator, a little bit to the fine tuner, a little bit to data owner, right? And it just accumulates over millions and trillions of tokens, and then you distribute it.
Awesome. So thank you very much. One last question for me, which is earlier we were talking about getting crypto networks to allocate 10% or more of their value flows to PGF. Are you guys going to do that?
Well,
putting you on the spot.
if we call training AI models a public good.
Well, it depends on how they're used, but.
Well, I mean, the goal is, as I said,
we mean also public goods more broadly defined than the direct production utility built into it. A national government with a large scale revenue flow has to take some amount of the proceeds and reinvest those into public goods that are hard to fund otherwise. And so crypto networks need to evolve this kind of structure of creating some value flow and then extracting some amount of that and recycling it back to broad public goods. So that's kind of more what we mean.
Yeah, I mean, we can discuss more on this. Right now, effectively, Near is functioning like that, except public goods are more limited to the Near ecosystem, right? Like reinvesting in infrastructure, reinvesting in kind of R&D more broadly. Near, for example, developed Borscht library that is used by Solana and by other people. So we are developing, and everything we do open source. The TE infrastructure will be open source as well. So you can kind of the idea you can use this on your machines as well, right? So not just in kind of shared cluster. And so anyway, I would say right now it's mostly through technocratic lens, because we believe that's the most impact we can do right now. But as Near network, grows to bigger and bigger, I'm sure there will be other opportunities.
It'll just be easier to do it now while the crypto market caps are smaller than later when justifying allocating an entire trillion is harder. Anyway, thank you very much, everybody. I really appreciate you being here. Thank you so much for joining us.